We code with stars, reaching for the sky. Each line a brushstroke, painting world.
Hi stars. Welcome back to our FastAPI Chronicles series on CodeStar, where we code with the stars. My name is Forster, and I'm here with you, because you are the star. In our last video, we dug deep into path operations in FastAPI, explored how to work with path and query parameters, and had some fun testing out our path operations in the Swagger UI. If you haven't checked that out yet, be sure to give it a watch. It's packed with essential knowledge to get you started with FastAPI. Today, we're shifting gears just a bit to talk about something super important when working with FastAPI, that is Pydantic. Pydantic is like your best friend when it comes to ensuring your data is valid and neatly structured. Trust me, once you get the hang of it, you'll wonder how you ever coded without it. So, stick around because, by the end of this video, you'll not only understand what Pydantic is but also how to use it to level up your FastAPI applications. Alright, let's get started. Pydantic is a Python library that helps you ensure your data is clean, valid, and well structured. Think of it as a data validator and converter all rolled into one. When you're working with APIs, especially in FastAPI, you often need to take in data from users, validate it, process it, and then send back some data after processing if necessary. This is where Pydantic shines. With Pydantic, you define models that specify how your data should look. These models automatically handle the validation for you, checking things like data types, required fields, and even complex relationships between different pieces of data. And if the data doesn't match what you've specified, Pydantic will let you know right away, so you can handle those issues before they cause problems in your application. In simple terms, Pydantic makes sure that your data is exactly what you expect it to be, saving you tons of time and headaches down the line. So, that's a quick overview of what Pydantic is and why it's such a powerful tool for FastAPI developers. Now, let's see how we can start using it in our FastAPI applications. Alright, let's get into creating our first Pydantic model. Pydantic models are essentially Python classes that inherit from base model. The base model is what gives Pydantic its superpowers. It provides the built-in validation, data parsing, and conversion that we've been talking about. When you define a model with Pydantic, you're creating a blueprint that not only specifies the structure of your data but also enforces it. Let's create a basic user model to see how this works. We'll say that each user has an ID, a name, email, and password. Here's how you define that with Pydantic. First, we're going to import base model from Pydantic. The base model is the foundation of any Pydantic model. It gives us all the tools we need for data validation and conversion. Next, we'll define a class called user that inherits from base model. This is where we specify the structure of our data. Inside the user class, we're defining 4 fields: ID, name, email, and password. We've also specified the expected data types for each field. So, the ID should be an integer, while name, email, and password should all be strings. By inheriting from base model, Pydantic ensures that any data we pass into this model is validated according to these types. If someone tries to create a user with an incorrect data type, Pydantic will automatically handle it, either by converting the data or raising an error. For example, if someone sends a user with a non-integer ID, Pydantic will try to convert it to an integer. If it can't, it'll throw an error, which helps prevent issues down the line. Here's a quick example of how you'd create a user instance with this model. We're creating a user with an ID of 1, a name of Forster, an email of forster@example.com, and a password of secure password. Don't worry about the errors in the console while I type. It's just my Visual Studio Code automatically saving the changes, which causes the Uvicorn server to restart since I'm running it with the reload flag. The server will automatically restart whenever it detects changes in the code. If you're using Visual Studio Code with autosave enabled, it always triggers these restarts each time the file is saved. When we print out the user, we'll see a nicely formatted representation of our data, thanks to Pydantic. Look how clean and structured it is. Pydantic takes care of formatting everything for us, from the ID to the email, so it's super easy to read. No extra work needed, just a clear representation of our data. It's like having a built-in data organizer working behind the scenes. Now, let's try changing the ID to 2, which is a string. Pydantic won't complain because it can easily convert 2 to an integer. Pydantic doesn't even flinch, it smoothly converts that string into an integer for us. This is one of the great things about Pydantic, it's flexible and intelligent, taking care of these little details behind the scenes so we can focus on the bigger picture. But what if we change it to something that can't be converted to an integer, like 2? Let's see what happens. As soon as we run this, Pydantic will immediately throw an error in the console, letting us know that the ID is invalid because 2 can't be converted to an integer. This instant feedback is one of the great things about Pydantic. It helps catch data issues early on, making our applications more robust and reliable. And that's it. We've just created a more detailed user model with Pydantic, adding a password field to handle user credentials. This is a great starting point for handling user data in your FastAPI applications. I'm trying to bring the terminal down so that you can see everything as I type. For some reason, I'm having trouble pulling it down right now, and I'm not quite sure why. Let me try a few things here to figure it out. Now that we've got a basic understanding of Pydantic models, let's see how we can use them in our path operations. Remember in the previous video, we created a path for creating a user that simply returned a JSON response with a message saying, "User created successfully." This time, we'll use the user schema in this path operation. But instead of manually parsing data from the request, we'll let Pydantic handle the validation for us. For now, we'll head over to the Swagger UI to see how the schema is displayed there. Let's also modify the path to return the same data to the user for the meantime. Now, let's test it in the Swagger UI. Yeah, there it is, pretty cool, huh? Let me update this with some more meaningful data. First, I'll change the ID to 2. Then, I'll modify the name to something. The email shouldn't just be any random string, so I'll update it to user@example.com. As for the password, I'll leave it as is, just a simple string. Once that's done, I'll go ahead and execute the changes. You can inspect the curl command in the Swagger UI and see how the data is represented with D, indicating the data we sent. Alright, our codebase is starting to get a bit clumsy, so let's clean it up by moving our Pydantic schema to a separate file. This is a common practice to ensure a clean and organized codebase. Later on, we'll dive deeper into how we can structure our files to keep everything on point. For now, let's create a directory named schemas, and inside it, we'll create a file called user.py, adding the .py extension to signify it's a Python file. I'll go ahead and copy the user class from our main file and paste it into the new user file. Good, now we need to import this module back into our main file to use it. You'll notice that our main file and the schema directory are both located at the same level in our project structure. This means they are within the same directory, which makes it easy to reference the schema without needing to navigate through multiple folders. So, we'll write from schemas.user import user to bring the user class into our main file. Now, we can use the user model here in the main file just like before. As you can see, our code is now much cleaner and more organized, and this will make maintaining and scaling our project much easier in the long run. Let me go ahead and test everything to make sure it's working properly. Alright, it looks like everything is functioning just as expected, no issues at all. Alright, now that we've integrated Pydantic models into our path operations, let's take it a step further by exploring validation and error handling. When working with APIs, ensuring that the data being passed in is valid is critical, and Pydantic makes this process seamless. We've already defined our user model with ID, name, email, and password. Each of these fields has a specific type, and Pydantic ensures that the incoming data matches these types before it even reaches our function. But how do we enforce more constraints on this data? That's where Pydantic really shines, with its built-in functions and decorators to add extra rules and validations to our models. One of the key tools Pydantic provides for this is the field function. The field function allows us to define additional constraints and metadata for each field in our model. For instance, you might want to ensure that a password meets a minimum length requirement or that an email address is properly formatted. Let's see how that works in practice. In this example, we're using the field function to enforce that the password must be at least 8 characters long. The field function is incredibly flexible. You can use it to set default values, provide metadata, or add constraints like we did here. For instance, we can set a description to explain the purpose of a particular field, and by setting minute_length equals 8, we ensure that any password passed into this model must be at least 8 characters long. If a shorter password is provided, Pydantic will automatically raise a validation error. Let's test this out in Swagger UI. First, let's inspect the schema. Navigate to the Create User endpoint and click on Schema to see the beauty of Pydantic's generated schema. We'll then try to create a user with a short password and see how Pydantic catches the issue and returns an error message. Pydantic has already populated this field with data that has a length of 8 characters. I'm going to go ahead and change that to 6 characters instead. This is a great way to ensure that your API only accepts data that meets your specific criteria. Pydantic functions are incredibly powerful and cover a lot of scenarios, but they do have their limitations. So what happens when we need to create our own custom validations? This is where Pydantic's decorators come into play, giving us the flexibility to enforce our own rules. Let's start with the field_validator decorator. This decorator allows us to define custom validation logic for individual fields in our model. For example, let's say we want to ensure that the email address is not only a string but also follows a specific pattern, or perhaps we want to confirm that a user's name doesn't contain any numbers. We can easily do that with field_validator. The decorator function takes in the class instance as its first parameter, often referred to as CLS, and the value being validated as its second parameter, usually named v. When we use field_validator, we can perform any checks we need on that value before it gets accepted by the model. If the value doesn't meet our criteria, we can raise a value error to stop the process and return an error message. This gives us an extra layer of control, allowing us to enforce rules that go beyond simple type checks. Next, we have the model_validator decorator, which is used when we want to perform validation across multiple fields or the entire model. For instance, we might want to ensure that a combination of fields meet certain conditions, like ensuring a user is at least 18 years old if they've provided their date of birth. We'll explore this in more detail later. If you're enjoying the content, I'd kindly ask you to subscribe to the channel so we can keep learning and building this community together. Your support truly means a lot. These are just regular Python methods. The only new aspect here is the decorator that we're applying to them. So, once you understand what you're trying to accomplish, you already have all the tools you need at your disposal. I'm going to go ahead and import the model_validator now. We'll circle back to it later and dive deeper into how it works. But for now, let's test our field_validator in Swagger UI. We'll try submitting invalid data for both the email and name fields and see how our custom validations catch these errors, providing clear feedback to the user. Alright, stars. Now that we've tackled validation and custom validators with Pydantic, it's time to dive into something really powerful, working with nested models. Nested models allow us to structure complex data more elegantly and efficiently. Imagine you're building an application where a user has an address, or a blog post has an author with additional details. Instead of cramming all that data into a single model, we can nest models within each other, making our code cleaner and more organized. Let's start by creating a couple of models. We'll create an address model with fields like street, city, and zip code. Then, we'll nest this address model inside our user model. This approach helps us keep related data together and makes our models more modular and easier to maintain. As you can see, we've added an address field to our user model, and its type is our address class. This means that whenever we create a user, we can now include an address object as part of the data. Pydantic will automatically validate this nested structure for us, ensuring that all the fields in the address model meet their requirements before they are accepted as part of the user. Now, let's test this in the Swagger UI. We'll create a new user, but this time we'll include an address in the request data. Watch how the nested model is represented and validated. It's really powerful and makes managing complex data structures so much easier. Go ahead and try creating a user with an address, and see how Pydantic handles the nested data flawlessly. You'll notice that even though we're working with multiple models, everything stays neatly organized and easy to manage. That's the beauty of Pydantic nested models. Your code becomes more modular, and your data more structured, all while keeping the validation process robust and reliable. You can even create more layers of nested models if your application requires it. We've explored some really cool features of Pydantic so far, but now it's time to talk about something that will make our models even more powerful and reusable: model inheritance. Just like in object-oriented programming, where a class can inherit properties and methods from a parent class, Pydantic models can inherit fields and validators from other models. This is super useful when you have models that share common fields or when you want to create a base model that other models can build upon. Let's dive into an example. We're going to create a base model called person that has fields like ID, name, and email. Then, we'll create a user model that inherits from person and adds some additional fields, like password. As you can see, the user model now inherits all the fields from the person model, ID, name, and email, but it also adds its own password field. This way, we're not repeating ourselves by defining the same fields multiple times across different models. Instead, we're using inheritance to keep our code dry, don't repeat yourself, and more maintainable. Let's take this a step further. Imagine we're building an application that has both user and admin models. Both user and admin share common fields like ID, name, email, and password, but maybe the admin model has an additional field like access level. We can easily extend our user model to create an admin model. Now, our admin model inherits everything from both person and user, and it adds a new field, access level. This is super powerful because it allows us to build up our models in a modular way, reusing common fields and adding specific ones where needed. Let's see this in action in Swagger UI. We'll create an admin user with an access level and see how Pydantic handles this inherited structure. The Swagger UI will reflect the fields from all the parent models as well as the fields unique to the admin model. This technique not only keeps our code clean and organized but also makes it easier to manage and scale as our application grows. If you ever need to update a common field, you just update it in the base model, and all the child models automatically inherit the change. So, go ahead and experiment with model inheritance in your own projects. It's a fantastic way to build robust and reusable data structures in FastAPI using Pydantic. I'm going to add the address schema to the person schema, and as you'll notice when we test it out in the Swagger UI, the admin schema will also inherit the address fields. This way, the admin will have access to all the properties of the address as well. We've covered a lot of ground with Pydantic so far, but there are still some advanced features that can take your data validation game to the next level. These features allow you to add more control and flexibility to your models, so let's dive right in. We can set default values for a field, add examples to make it easier for users to understand what kind of data they should provide, and even set constraints to ensure that a particular value is greater than or less than a certain threshold. There are a lot of powerful options you can explore with Pydantic fields. Here's a quick example. In this example, we're using the GT, greater than, and GE, greater than or equal to, validators for price and rating. If a user tries to set the price to 0 or a rating outside of 1 to 5, Pydantic will raise a validation error. We've already seen how Pydantic's built-in functions work for simple validations like type checking or ensuring a field meets certain criteria. We've also looked at how to perform more custom validations or transformations. Let's now look at modes of the model_validator decorator. I told you we will come back to this. There are 3 main modes you can use: before, after, and wrap. Let's break them down with an example. First, let's look at the before mode. This mode is triggered before the Pydantic model instance is created, meaning the data is still in its raw form, as a dictionary. This is useful when you want to clean or pre-process data before it's validated. Here's a quick one for you. In this case, we're making sure that the age is positive before the data is validated and before a user model instance is created. This is why we can use dictionary operations like values.get age here. If the age isn't provided, I'll simply set it to 0. Otherwise, I'll take whatever value is given and return the absolute value of it. It's a straightforward approach and ensures we always have a valid age to work with. Now, let's talk about the after mode. This mode is triggered after the model instance has been created, meaning you now have access to the fully constructed object. This is ideal for validations that need to consider the relationships between multiple fields. Here's an example. Here, the check_passwords_match function ensures that the password and confirm_password fields match after the user object is created. Notice that we're accessing values.password directly, which works because the model instance has already been constructed at this point. Let's test this out. Refresh the browser, quickly inspect the schema. Now, let me play around to see if everything is working. I'll set the age to -1 and make sure the email is invalid. Oh yeah, Pydantic caught me, invalid email. Let me change the email to star@gmail.com and test it again. Error, passwords don't match. Let me make sure they are the same. Now, see, it works. As you can see, the age has been converted to 1, and that's exactly what we wanted our model validator to do. If we change the condition to values, password, instead of values.password, we'll get an internal error because the after mode operates on a fully constructed object, not a dictionary. Go ahead and try it out in your code. Change the condition and see what happens. Finally, there's the wrap mode, which is a bit more advanced. The wrap mode allows you to wrap the entire validation process, giving you control over both the input and output of the validation. This mode can be useful if you need to do something special with the data before it's passed to the validators, or if you want to handle errors in a specific way. We may talk more about it later. Now, I know this might feel a bit overwhelming at first, but don't worry. If you don't fully grasp everything right away, that's totally okay. The more you work with these concepts, the clearer they'll become. Just stick with it, and you'll get the hang of it in no time. So far, we've been focusing on validating and handling the data that comes into our API. But what about the data that goes out? That's where response models come in, and they are just as important for ensuring that our API returns clean, consistent data. Before we dive into the details, let's take a moment to inspect the Swagger UI. If you look at the responses for our paths, you'll notice that they are all set to string by default. Why is that? Well, it's because we haven't specified a response model yet. Without that, Pydantic doesn't know what we intend to send as a response, so it defaults to string until we tell it otherwise. Let's change that. We can set the response model for a route to ensure that the data we send back meets certain criteria and is consistent with what we've defined. Here is a quick one. Here, we've created a user response model and specified it as the response_model for our user's route. Now, whenever we hit this endpoint, the response will be validated against the user response model before being sent out. This ensures that our API returns a consistent structure, and it's especially useful when working with client applications that expect data in a certain format. Let's head over to Swagger UI and try it out. You'll see that the response schema now matches the user response model we defined, instead of just being a generic string. This is a huge win for maintaining consistency and clarity in our API responses. But remember, in real-world scenarios, the responses aren't usually hard-coded like this. They often come from a database, and we'll get into that in a bit. But for now, just know that setting a response model is a crucial step in making sure your API behaves as expected. So go ahead and give it a try. Set a response model for one of your routes, inspect the Swagger UI, and see how the response changes. It's a simple step, but it makes a big difference in the quality of your API. Let me make sure the password and confirm password match. Now, let's execute it and see. Oops. Internal server error. What's going on here? Let me check the console. User object is not subscriptable. Oh yeah, I forgot to undo the changes we made to the model validator. We were trying to apply a dictionary method on an object. Let me fix that back. Now, let's go back and test it again, making sure the password and confirm password are the same. Oh yeah, we get the user ID, name, and email as the response. That's exactly what we specified in the response model. Before we move forward, it's important to note that Pydantic has built-in validators for common data types, including email addresses. This means you don't need to write a custom validator for emails unless you require a more specific email pattern. Pydantic's email validation covers the standard format, which is usually all you need. Let me check the schema in our good friend, Swagger UI. You see, Pydantic is smart enough to recognize that this is an email field, and it has already provided sample data to illustrate that for you. Isn't that wonderful and beautiful? And that brings us to the end of this series on FastAPI and Pydantic. We've covered a lot, from the basics of setting up routes and working with data models, to advanced validation techniques and handling responses. You've gained a solid foundation that will help you build robust APIs with confidence. Remember, the key to mastering these concepts is practice. So, keep experimenting, building, and refining your skills. If something doesn't click right away, don't worry, take your time, revisit the material, and it'll start to make sense. Thank you so much for joining me on this journey. I hope you found these sessions valuable and that you're excited to apply what you've learned in your projects. In our next video, we'll explore how to connect our application to a database, bringing our API to life with real data. It's going to be a crucial step in building a fully functional application, so make sure to tune in. If you have any questions, feedback, or suggestions for future topics, drop them in the comments below. Don't forget to like, share, and subscribe to the channel if you haven't already. Your support means the world to me. Stay tuned for more coding adventures, and as always, keep coding with the stars. Until next time, take care, happy coding, and don't forget, you are the star.